Welcome to the video lecture on simulation of solid state drives using MATLAB Simulink. In this video, we are going to see how to simulate a closed loop system for a DC separately excited DC motor using fed from a chopper. So let us go into the simulation. Let me take a new Simulink model, blank model, and I'm going to a library browser. In the library browser, I go to Simscape. In Simscape, go to electrical. In electrical, specialized power systems. Under specialized power systems, electrical machines, and I take a DC machine and keep it on the untitled uh, Simulink model file. Now I need a sources, DC source to excite armature and field. So I take the DC source and excite with the armature. In order to note down the field current, let me take the measurement, current measurement, and put it on the screen and rotate it so that I can connect the current measurement block, something like what I'm showing in the figure. I connect everything like this. Okay. Now I need a scope to view this current. So Simulink syncs display. I put a display it here to see the what is the value of current which is fed into the field winding. Double click on this DC motor machine, go to the parameters, go to the configuration, keep the first preset model as the parameters. That is 5 HP, 240 volt armature, 1750 RPM, field voltage of 300 volts. So let me have a field voltage of 300 volts here. Apply and give OK. Now I need another supply which is of 240 volt, which is required for the armature, and it has to be given through a chopper. So chopper, I need power electronic devices. I go to power electronics, take a IGBT with diode chopper. Now to create a chopper, I need two devices with of IGBT with diode. So I put two devices, two IGBTs connected in the fashion of how I'm showing here, in a very similar fashion. Like what I'm showing here. Just connecting the chopper. And this is the chopper. I don't want this measurement port, so double click, remove that measurement port in both the devices. Okay, good. Now let me go to the uh, bus selector, connect the measurement port here, double click on this bus selector, remove this signal 1, add all the signals, add all the 4 signals, and remove this signal 1 and signal 2, and speed is supposed to be the first parameter. Okay, no issues. I will have it like this. Then increase the width of the bus so that I can connect it comfortably in my screen. Now I need a scope to display all this. So let me try to take a scope from the Simulink Syncs scope. First is electromagnetic torque as per the bus selection. Second one is field current. Third one is armature current. And fourth one, actually the speed will be in radians per second. So I put a gain block to convert that radians per second into RPM, for which I put a gain block, double click on this gain block, give 60 divided by 2 into pi, 60 by 2 pi will give me the radians, will change the radians into RPM, radians per seconds into RPM. Okay. So now let me move this and have it comfortably on my screen to view all the parameters. Okay. Now I need a PI controller to control all this. So let me go to library browser, take a sum block, double click, change one of the sign to negative because I want to take an error, and go to again Simulink continuous PID controller, put it on the screen. This is the speed PI controller, which is used to control the speed. Let me adjust all this. Then I need another block, another PID controller. This is the current PI controller, and the output of this should have a gain block. This is to reduce the voltage, control voltage to a value within 1. So 1 by 240 is supposed to be the gain of this block. This is 1 by 240 by 240. Let me adjust all this. Then I need a PWM pulse generation, for which again you go to Simulink library browser. Under power electronics, you have power electronics control, and that control you have yes, there is a PWM generator, duty cycle to PWM generator. So I will connect this to this output, and I can connect the PWM pulse to the gate of the first device. And let me little bit reduce all this so that it will be comfortable for us to put it on the screen. Okay. Now I need a NOT gate. You can go to Simulink, commonly used logical operator. Double click, put a NOT, give this NOT signal to the other gate pulse. So this is the second one. Now I sense this speed which is available here, give it the outer loop, and current which is available here, give it to the first loop, inner loop. Let me have the step input to give a step input to the input at the speed change. So let me connect a step input signal here and also at the torque. So this step input, let me assume that at fifth step it is going to change from 1500 RPM to 1700 RPM. Then here at the third second, initially it is running at no load, and at third second it is going to 20 Newton meter of torque. Apply, give OK. This PID controller need to be changed to PI value, and this value is supposed to be 0.45, and integral controller integral is 1.25. Click apply, and saturation level is supposed to be 25 and 0, the current limit of saturation. 25 and 0. And for the second PID controller, again double click, go to PI, and its value is 6.41 and integral is 1121.89. And the saturation limits are 240 by 0. 240 and 0. Click apply and give OK. And I put a display to display the speed so that I could able to see what speed it is running. So let me have it somewhere here. A little bit adjust all this so that I will have a good adjustment to see everything properly. Yes. Now again Simulink library browser. I go to specialized power systems, put a continuous power guy in order to initiate the simulation. Save this file in some test3 file. Save this and debug. Go to diagnostics, Simulink diagnostics, solver. It is ODE 23 TB. It is 1 e power minus 5 and 1 e power minus 6. Apply. Minimum step size and maximum step size is supposed to be like this. Apply and give OK. Everything is set right now. Now let me run this simulation and see what is happening. Just look at this. Initially the speed is running at 1500 RPM because my initial speed is 1500. After 50 second it goes to 1700 and at third second the load is changing from 0 to 20. Let us wait for the simulation to complete and see what is happening. And at the 50 second I said that the simulation, the speed will change. Now look at this, from 1500 it is going to 1700. So the closed loop is working perfectly. And this is supposed to be the chopper fed. This is chopper fed DC motor. This circuit is what I mention it as a chopper. So let me complete this. Simulation is completed. Now double click on this. Sorry, now I want to look in the speed. Speed is the last one. Double click on this. Look at this, the speed is changing. At third second there is a change in load torque. So at load torque is from 0 to 220 it has went. So there is a small disturbance and again the speed is settled. At this point I am changing the reference speed from 1500 to 1700. Again the speed is moving from 1500 to 1700. Look at the armature current here. Armature current is initially very low value. At third second I am increasing the load. So the current is also jumping. So if you look at the current, since there is a load at third second, the current is also increasing from 0 to some prescribed values. So since there is a limit of 25 amps in my PI controller saturation point, the current is not allowed to go beyond 25 amperes. At this point, since there is again a change in speed, there is a small oscillation, again it comes back to the same current which it was taking earlier. So all these are being controlled in a proper fashion. So this is what all about the simulation of uh, converter DC chopper fed DC motor, uh, and I can also look into the armature voltage, how much it is being fed. So for which I can go to Simscape, uh, electrical, specialized power systems, sensors and measurement. I can just take this voltage block, put it on the screen and connect it to something in order to measure the armature voltage. Now to measure the armature voltage, let me take this 2 and put it on the screen, something like this. Let me adjust all this. Okay. Now I need to view the output. So for which I need a mean block, because this is not a uh, continuous value. So it is a mean. Since the switching frequency is 5000, I want to uh, find out the values for 5000 value, and let me display the voltage here. Voltage. So now again if I run, yeah, initially the voltage is around 180 volts, which is fed 170. Let me settle. Once it is settled, it will also settle. So 1500 RPM, around 160 volts is given to the armature, which is varied via the DC chopper. Once at the fifth second, as I said, there is a change in speed from 1500 to 1700. Yes, now there will be a change in speed from 1000. Yes, now look at it is almost 235 volts. Earlier it is around 212 something. Now it is 235. At the third second, there is a change in uh, torque, because of which there is a small oscillation in the voltage levels. So this is what the ultimate understanding of this chopper fed separately excited DC motor speed control mechanism. And at the end of this simulation, you could able to take all these graphs and paste it on the document for the verification and submit it for the verification signature. And this is the output of the voltage and current. And that's all about this particular video. Thanks for watching. Thank you.